Hey, hey. How's everyone doing tonight? Doing okay? Ooh, that's like really quiet. Ooh, what's going on there? Okay. All right. Um, tonight I'm sounds good. Cool. Um, tonight I'm just kind of I'm doing a test stream on YouTube right now just to see if my internet connection can handle both happening at the same time. Um, I'm hopeful that they will. But we're gonna do that for just a little bit, probably like a half hour, 45 minutes. Um, then we're gonna work on some FFI for Python as well. Deal with that mess that I'm working through. Um, they really don't want you to try to do things parallel, so we'll see how far we get on that. Uh, all right, let's see. Um, cool. Main. Nope, not this one. Source lib. Um, we need some OpenMM stuff as well. Also, WarpTux, thanks for the sub. I appreciate it. All right, come on, OpenMM. Let's. Not, it's not even OpenMM. It's just Firefox being Firefox today. Yeah. Okay. Um. So a couple changes from when we last were working on this. The big one is basically that um, we have to work with more kinds of records. So basically, like we have a chain, which is a collection of residues, which we're working on getting that right. We're not quite there yet. Is this the right file? Yep. So basically, you have chains, which have basically these various collections, um, and that's kind of what I'm working on here. And then we have these various sequences as well. And I'm just trying to see how much of this we can get going. The problem is that we've started to do this in a parallel iterator. So when we do that, it gets kind of weird because we have this very strange parsing that we have to do. So what this is doing is like with the fold operation is you're parsing them in parallel and they're doing the operations and merging them into an accumulator. And then what happens is then at the end we reduce those into a single object. So in this case, we're putting it into both the atoms and then the models, which are being parsed from model records and the atom records, which is kind of interesting, but it's also very strange as well. Yeah. And so this is interesting too, because like what it's trying to put the different atoms into different models, which makes a lot of sense when we think about it, but it's kind of hard to figure out how that maps correctly. So how we were doing this in currently we actually don't have any way of doing this. So we need to figure out how to get that the relationship between the two working. And I just haven't found that yet. Um, but the goal is that eventually we will, right? Is that we'll have some sort of way to map between between these atoms and the models themselves. But we are not quite there yet. Cool. So current model append connects. So we're not really doing this exactly the same. This is parsing each line, so that's roughly equivalent to what this is doing here. Um, if it's an atom or a command, we add the atom line. Why are your viewers streaming rat ASMR? What does that mean? Where is this coming from? I have no idea. That's a first for me, honestly. I don't even know who this is. I really did not need that in my chat though. I'm gonna be honest. Oh goodness. Yeah, I did not need this right now. What is this? Okay, yeah, that we're gonna pretend like I did not just see that one. But okay, more power to you, man. You know, do what you need to do. Okay. Ban them. I didn't even know like I don't know. I have no reference to this. Are they even commenting? They're not even commenting in chat, right? Am I wrong about that? I see. Yeah, that is wild. That's weird. Wild. Python Rust FFI. Great question. Um, so basically, what we're doing right now is we're trying to convert this OpenMM code, which does molecular modeling. We're trying to convert this into this Rust code here. So what we have is currently we have a way to parse these protein databank files, but we need to actually do stuff with them now. And we kind of have a rough structure to like generically do that, but it's not currently there yet. So we're trying to get that figured out. So yeah, right now, so to kind of demonstrate like what we're kind of how that looks is from a Rust perspective, this is kind of ugly right now. This is not pushed yet because I am not proud of how this looks, but we will get there. So basically what happens is we have this, we have various ways to parse PDB. So this is like a parallel way to do it. This is a way to do it single threaded. And then you have a way that's yeah, so why do you need FFI? Yeah, exactly. So the goal is that we're going to keep all of the code base in Rust, and then we're going to do as much of it. We're going to do as much of it on the Rust side, and then just return the objects back to that without having to worry about the global interpreter lock. So how PyOxide, which is the library we're using here, kind of works is we don't really need to hook into the global interpreter lock until we are moving values into it. So a lot of this computation is happening before we even have any values being used. So like, for example, all of this code is running, not this one, it's down here. All of this code runs and is not touching a Python value until we return it, right down at the bottom. And what that allows us to do is really to go through and say, okay, cool. like we have all of this, it allows us to do a lot of parallel processing very quickly without the need. And to just kind of demonstrate that, kind of the difference here, let me check. Yeah. Okay, cool. So we can quit out of that as well. So if we do like Python, or we need to source, and then we do Python test.py. This is going to kind of compare it. It's not really a great comparison yet. We're working on it. But really what it does is that just ran through and did that parsing 10 times over that file. And then these next 10 lines are going to be the same operation, or a similar operation, but we're doing it in Python. Now, the thing is like that's a single threaded operation. There's no parallel processing on this specific part of this. So we have to kind of that kind of causes an issue. So by leveraging Rayon, we don't have to worry about the global interpreter lock to actually do any of the processing here, which is really nice. And as you can see, it takes about 10 seconds to do, which can be kind of wild. Granted, now the one thing I will say that is like kind of ridiculous is how we get all of these pieces talking correctly, because typically like all of this code was originally written with that single threaded kind of programming in mind, and porting it is not exactly like a one-to-one operation. So that's kind of where we're at right now. But yeah, as you can see, this takes like forever. Now, there's other operations it's doing, right? And so like it's important to note that like I'm not doing all of these operations. So like for example, right now the case I'm handling are these lines and these lines here, and almost these lines as well. But we also need to be able to handle these records and these records and these records here, and make that kind of work. But the goal is to keep as much of the like minimize the Python surface, kind of similar to how Polars did with their library. So Polars, right, is like a really highly parallelized alternative to Pandas that uses a similar idea. So it's using Rust under the hood and utilizing as much of that throughput that we can get with Rust, and then we kind of just like expose a thin little layer over to that. I dig this. I dig these little hype guys. Yeah, it's been a fun project. So, admittedly, this all started as a Zig project. I tried to do Zig FFI. I do not have time for that. I barely have time to do this with Rust FFI, but we're gonna try. We're gonna try to get that moving and grooving. So the thing that we're trying to figure out here is this was we did add model, which basically I think it's this one. Yep. If there isn't a model, add the model. We append to this model list, which we can basically say is here. Yeah. So it's like this kind of maps similarly to this here. And then we can get a specific model by the model number. Not exactly yet, because this is technically like a list, I guess, but it maps roughly for the time being until we need to make that more precise. So we have the models here. The next one I kind of want to do is get the chains. So iter models. So we go through all the models, and then we iterate through self dot. Wait, is that a recursive call? Iter models is calling this. iter models. I don't know. Let's see. So iter models is hmm. So this is kind of what we're doing here. It doesn't, like I said, it doesn't really map one to one. So we're adding the models to the list. We get the model number, then we add it to the list of that type. What is this? Oh, it's a class. Okay. We add the model. So we do something similar, but not quite. We set the atom numbers in this, and then when we get to an atom record, we add the atom to the current model. Atom.model number equals this. Self.current model. So that's the residue. Is this really going to have me check out? I do not want to install a Python LSP right now. I am not feeling like this. Do I even have one? I don't even think I have one. Let's see, I think I have one configured, but no, what is it? NVIM. I know I have one like set up, but I don't think I have it installed right now. Let's see, LSP. Go please, MLS, Arduino, Astro, Pyrite. Is Pyrite like what's being used right now by Python devs? I don't. We can go to NeoVim LSP. Let's look at that. I know about Anakin. Is that? I thought there was like another one. What are all these requirements? Why do I have to have all these requirements? What is going on here? Nothing. Okay, cool. Yeah, we're not doing that. Let's see. What is this one? Ansible. Yep. That's kind of cool. Blueprint. Yeah, EFM does. Jedi. I'm familiar with Jedi. I've used that. PyLSP I've heard of. A fast static code analyzer and language server. And it's written in Rust, baby. There we go. That's what I'm talking about. All right. Let's see. Pylizer. Oh, there we go. That's it. That's the one. All right, cool. All right, so let's check the config on that. Pylizer. Yep, so that's cool. Pylizer. Cool. So we have that there. And then man, they're really original with the Python language server names, huh? Let's see. Let's check Pyre. What is this one? Oh, only does diagnostics. Yeah, I don't. I thought there was another one. I thought there was one like oh, who is that one? Is it Rough? Format, quick fix. What is this for? Fix all, interpreter, lint args, lint enable. Doesn't look like it does like go to definition. I don't know. I don't know if it does go to definition or not. Supports rough diagnostics, provide code actions to fix them, but it's not use a lot. Another LSP to do auto completion navigation. Okay. Great. And okay. Well, that checks out. Okay. So that's that. And then we can do home manager, LSP, and then all we have to do is packages dash pylizer. Just switch. I did. Did I not? Oh yeah, I did it backwards. Gonna swap to Emacs 2 while you're at it? No. I like my pinky in the position that it currently is. I don't need a condition with my pinky. I'm good. All right, cool. So let's see. Test dot py. Py module time has no. Well, that's just not true. Okay, so we need to figure that out too. All right, let's see. Can I like drop a config file in here to say like, hey, Okay. Inlay hints. So is there really no way to like specify? That's kind of weird. Erg language server. Limitations. Is there like a wiki? No. Hmm. Well, maybe not. It's largely due to the fact that it's implemented in Rust. Okay, but like, how do I specify the Python version? Because I bet it would. Oh, I bet I. No idea what I need to do. Yeah. Let's see. It's weird that it can't even find this one, like time dot monotonic. That is definitely a thing. Oh, you know what we can do though? This would be kind of a smart way to do it. We can do this. I think we can just pip install it here, and that should be. Oh, oh, that would do it. Yep. Now we should be fine. Nope. Okay. Well, this is where Nix will help us. Hey, Nightshade. It's been a while. I haven't seen you in a bit. Well, I've seen you in other streams, I just haven't seen you here. Let's try this. nbam flake. Let's do Python 3.11. So if I do like which Python. Yeah, yeah, no, I get it. I hear you. Right, so let's deactivate source. Let's try to reactivate it. Oh, right. So that's a pip install Pythonizer. Okay, is there something I'm not understanding here? Like, it's in the virtual environment. Why is it not able to find the module? Like, okay. Well, we'll solve that problem later. But for the time being, then, so we'll just disable it right now here. Just switch. We'll do that. We'll modify the flake again. Pull this out. Okay, cool. Pythonizer. Okay, so yeah, that's just not gonna pip. Is it uninstall? Yep. Yeah, that's fine. Thank you. Okay, so all this to say, Python tooling is still as amorphous as I remember it. So let's, in the meantime, we'll clean up some of this. Unfortunately, I do have to get going, but I will be back tomorrow morning. Um, just as a heads up for anyone who's interested. And it looks like the stream uh, on YouTube is looking good too. So we might attempt a YouTube stream tomorrow as well. So keep an eye out on X for anyone who wants to do that instead. All right, cool. So we don't need this. All right, so let's just clean up some of this and then we can get moving. Okay, so I think the other thing we'll need to do is we do have to do like a top dot atoms equals what? No, we have to do this operation here, which is the reordering of them. Oh yeah, this is gonna look like a how did I do that before? Oh, I didn't. Okay. Oh yeah, because it's not even the right type. Because it's technically a records uh, atom. Whoa, what in the heck is that? Hold on, did I get this backwards? Hold on, let's rethink this. Okay, so we get the atom records. We say if right, so let's take this code from up here. Okay, so we get each atom. We say let uh, atom or if let. So that's the underlying atom type. Yeah, which is an atom record. Right. Okay. expected atom record got found, or expected type atom record found record. Hmm. Oh yeah, because it's not really like that kind of thing. It's not an enum like that. It's just a pi atom, a Python atom record. No, it's not it. It's a record atom. Yeah, that one. Uses struct pattern syntax instead. No, we are. Yep, I appreciate it. No worries. I'll probably hop off here in like 5 minutes or so. I'm just gonna, fight with Rust and then get going. Expected tuple struct or tuple variant found struct. Let's say record. Oh, so we can just do like atom.ar. Yep, there we go. And then that puts it all in the right order. Nope, not go. Wrong language. Maturin develop. Python test.py. Not bad, but I really don't like that we have to do that, but I don't. Well, yeah, I think that's what we're gonna have to do. All right, chat. Thank you very much for stopping by. I appreciate it as always. I'm gonna get going, but I hope you all have a great night, and I will talk to you tomorrow. For anyone who wants to come out and hang, 8:30 or sorry, 7:30 Central tomorrow morning. So yeah, nice seeing everyone, and hope you have a great day. Take care. And if it will just, yeah, there we go.